And for students who just joined, I have one. Who else? I think there are 2 or 3. They're not here. I only have one student who's... Okay. So I'm ready. Again, you said number 11 on page or section at least.
Page 102.
102. So let's take a look in 102. And number 11. It says plot the given point in a rectangular coordinate system. Is that the question?
Mm-hmm.
Oh.
I just don't remember how to do it because the fractions.
Oh, that's you divide 7 by 2, you get 3.5, and you put at 3.5, comma, negative 1.5.
Okay. I just can't remember.
Yeah, so you 7 halves, negative 1 half. So this is 3.5, 1, 2, 3, 4, and this is negative 1 half. So this is negative 1, negative 2, so this will be here. At 3.5, comma, negative 0.5. Good. Anything else? Anything else? Okay, then let's move on. I'm assuming you are keeping up with me. Yes? Yes? Is that a good assumption or not a good assumption? So here's where we are. We're trying to see if there is anything else from 1.2, and we are trying to finish this as much as we can. Okay, 1.5, 1.6, 1.7. So on page 120, we only looked, if I remember correctly, and I should do this, and I like to do this. I didn't do it right now, and I will. I'd like to go back for a second, back to the previous lecture, and go over the lecture notes. Okay, so we identified terms, we identified factors, we know the difference between the two. We have an agreement. This is our agreement on 3 different special products. Then we filled out the agreement, and we had examples. And then we graphed a linear equation or function using x and y intercepts. And what else we did? We graphed the absolute value function or equation if you want. And we realized that whenever we graph a absolute value function, that looks like a V. It could be this if the leading coefficient are in front of the absolute value, or it could be this if it's negative. We identified domain and range. We talked about those. We solved the linear equation, and then we solved a rational equation. We refreshed our memory on division by 0, which is undefined. And then we solved it. No, we didn't. Ah! Okay, so that's where we are. So let's, I'm going to copy the original equation, which was 2 divided by x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1. This was the, this was the original equation. And we took it to, and I know I went over 2 minutes, and I promised to finish 2 minutes early today as a token of respect to you and your time. So 2x minus 2 minus x minus 1 minus 2x divided by x plus 1, x minus 1 equals 0. Right? That's where we stopped. Agreed? Perfect. So now, what would be the next step? What should I do next towards solving for x? Yes, I have to combine like terms at the top. So please combine like terms and tell me what is left. This is what you would have said, correct? Okay, perfect. Now, tell me whether I could write 5 as 5 over 1. Can I write 10 as 10 over 1? Would you agree with 0 as 0 over 1? Good? Yeah, 0 over 1 is still 0. Okay, so let's look at this. And yes, this is still a rational equation. Rational equation. But what type specifically? Another very important term to be written in that little notebook with terminology and important information that we learn every day. What is the name of this?
Equality.
The inequality will be, oh yeah, it's an equation. Name. It's still a rational. Okay? Proportion. It is a proportion. A proportion is a fraction on one side and a fraction on the other, nothing else attached. So imagine that it has a name. It must be important, right? Okay, why is this important? Why is we really have to give a name to this? Because only in a proportion I can. Awesome. Only in the proportions, thank you, Chip. AD equals BC. Only in a proportion I'm allowed to cross multiply. So I'm coming back to my problem. I changed the original equation into still a rational equation, but that is a proportion. And now I would like you to tell me what you get when you cross multiply. Now I can do this because I changed it into a proportion. So, can anyone dictate the next step? Negative x minus 3 equals? 0. Awesome. Now, what type of equation is this? Awesome. Only in a linear equation, I separate the terms. So let's separate the terms. You have a negative x on one side, and you are moving the negative 3 to the other. When I take negative 3 from here and move it to the other side, what do I do actually? So what is left? So from here, I have x equals? Awesome. I have a little question mark because I have to go back and check, yes, and see. We had two restrictions. I didn't copy them, but we had two restrictions, x not equal plus or minus 1 at the beginning, last time. So is negative 3 here? No. So it's okay. That is the solution. Awesome. Any questions about solving rational equations? Should we pick another? What did I do with what? Say it again.
1 and out. Oh, we did this last time. You have it in your notes from last time. I didn't copy all the steps. So 2 times x is 2x, 2 times negative 2 is negative 2, minus x times x, minus x times 1, minus 1 times 1 is minus 2x. So we had this. So if you want to write it down, 2x minus 2, yeah, 2x minus 2, minus 2, minus 1 times x, minus 1, and minus 2x. And we took it from there, simplifying. Is that okay?
So then 2x with negative 2x went away. So we had negative x, and negative 2 minus 1 is negative 3.
Did you multiply to get it out?
I multiplied the number or the expression by what I had in the numerator. Is that okay? Let's do another. Let's choose one more and then move on. Okay? Do I get to choose or you want to choose? Okay, let's say 49. On page 120. 1 divided by x minus 4 minus 5 divided by x plus 2 equals 6 divided by x squared minus 2x minus 8. It was broken into two parts, into two different classes, so I think we should do one more. Okay, first step, please. Can anyone tell us the first step? Very good. Yes, I completely agree. Although I would have waited to factor the last denominator before writing the restrictions, because I may factor now and I may forget. Most probably it will be the same. But still, I would have waited to factor the last denominator first before writing restrictions. But yes, that's the key. So to write that. So 1 over x minus 4 minus 5 over x plus 2 minus 6 over equals what?
0.
Awesome. Over what?
X minus 4 2.
Right. X minus 4 and x plus 2. So I was expecting that. But just to be cautious, to always look at the last or factor everything before you state restrictions. But yes, we were expecting that. Good. So these are correct. What would be the next step then towards? First, let's establish, correct, let's establish the least common denominator. Of course. Now the top needs what it does not have. And the top needs, and I shouldn't even bother with that, 1. Good. So 1 distributed to x plus 2. What do I get? X plus 2. Negative 5 distributed to x and negative 4. Negative 5x plus 20. Very good. And then finally, minus 6. Awesome. Good. Next step. So the denominator is this. What do I do with the right-hand side? 0 over 1. And the left-hand side at the top is? So this is 22. That's 22. 22 minus 6.
22 minus 26.
22 minus 6.
Oh, minus 6. I'm 16.
Awesome.
Oh, right? 16.
Is that okay, everyone? What type of a rational equation is this? Proportion. What do I do in a proportion? Excellent. So from here, what do I get? Awesome. What type of equation is this? Linear indeed. I'm allowed to separate. I have to separate the terms with x from the terms without x. And then finally I get negative 4x equals
4.
very good. And you're right, x equals 4. Not so fast. And what do we conclude? Right. And the equation? The equation has
No solution.
no solutions.
How do you get the x to not equal?
X minus 4 cannot be 0, which means x cannot be 4. X plus 2 cannot be 0, which means x cannot be negative 2. Is that okay?
Yes.
Perfect. Good. Anything else? I know you understood the steps, but if you don't go home and practice with 10, 15 problems, you're not going to remember. Okay?
Excuse me.
Yes.
No, x cannot be 4.
4 minus 4 will be 0. 0 in the denominator is not allowed.
Okay.
Better? Perfect. Okay. I'm moving on to quadratic equations. Section 1.5. Okay. Can anyone give us an example of a quadratic equation? Well, the general form is ax squared plus bx plus c equals 0. This is the form of a quadratic equation in which a, b, and c are real numbers. And what is the number that a cannot be? There is no denominator here, so we can think in those. Yes, why a cannot be 0? Because if a is 0, what happens to this quadratic equation? We say it collapses into a linear. If this disappears because the coefficient is 0, then this is no longer quadratic. B and C can be 0, but A cannot. Very good. We have 4 different methods of solving quadratic equations. And you can say, what for? Why do we need 4? Well, because of different applications. Different types of equations are easier solved with a particular method than another. Okay, so 4 methods of solving quadratic equations. The first one is factoring. I gave you a handout on factoring. And the handout also had this attached to it, which is basically a summary of any type of factoring that we will see in this class. When I'm given any polynomial to factor, the first step is I'm going to arrange it in descending order. The second step is I'm going to, and these two can go in one step. I'm going to factor out the greatest common factor and the negative leading coefficient. So these can be done in the same step. And then I will divvy up depending on the type of polynomial. If it's a binomial, I have to think in these terms. These are the special products. If it's a trinomial in this, these two. Or special situation in which these are not perfect squares, but they have the leading coefficient 1 or not. And if it's a polynomial, the only chance I have is factoring by grouping. That's the easiest possible. This is the second easiest, and of course the trinomial is the most difficult. Okay, so let's look at what I would like you to do is, this is the handout that I'm talking about. It has absolutely everything in there. How to factor a binomial, how to factor a trinomial, and how to factor a polynomial. And all these, this and this, are solving equations. So all these are equations solved by factoring. So in order to illustrate solving equations by factoring, we can go ahead and do this. Choose from here, or we can choose from the book to illustrate how we solve quadratic equations by factoring. Now, I would like you to try each and every problem from here. I did not write solutions, but I can post. Sure, I can find the video in which I presented each and every step here, absolutely everything. So if that's what you want. Any questions? Yes. No, the question is if you would like me to review any of the factoring, binomial, trinomial, polynomial, or if you'd like to go directly to solving equations by factoring. Yes, please, Chip.
When we factor these, are we using real numbers or do we use complex numbers?
It's a very good question. When we say that a polynomial is factorable, we really refer to real numbers.
Okay, how do you factor a squared plus b squared?
You can't. We will say it's not factorable using integers. That's the correct explanation. But yes, you're right. It's a plus bi times a minus bi. I know. But we do not think when you talk about factoring, we are talking about real numbers. And basically not even real numbers, but integers. We're not going to factor with 3/2. So, okay. So question, do we need to review factoring or we move ahead to solving quadratic equations by factoring? Binomials, trinomials, polynomials, or equations? The reason I'm asking is because I don't know where everyone is when it comes to factoring, so I don't know where to start.
Can we start with trinomial?
Yes,
If that's okay.
yes, of course. Okay, so let's start with trinomials. So when it comes to factoring trinomials, we have two special products. And if you remember, I'm trying to find my handouts. That I gave you last time, which is our agreement. I had enough. I'm not sure what happened. I have to give you two. One you keep and one you sign and you give it back to me. Yep. Yep. So I'm not sure why my handout disappeared. It must have been sweet. And got it. Right? The first two. So that's why I said we have to move away from foiling because going backwards, we are factoring. These are the two that I mentioned here. So what is the answer for the first one? Yes. This is a plus b everything squared. Awesome. What is the answer for the other one? Awesome. So when I try to factor a trinomial, like let's choose an example. Let's choose an example from this set, and then an example from the next set, and so on and so forth. So let's choose an example from the first set. Please choose. Okay, we want to choose b. So we have negative 3x squared minus 12x and minus 12. I follow the strategy to the T. This is the strategy. Factoring a polynomial, first I have to arrange it in descending order. Is it arranged in descending order? Perfect. Step 2 and 3 can be combined. I have to factor out the greatest common factor and the negative leading coefficient if the leading coefficient is negative. What will you factor out? Very good, awesome. Negative 3. What is left in parentheses? X squared, very good.
4x.
Very good. Careful. Careful.
Plus 4.
Let's try. Let's try. Negative 3 times x squared is negative 3x squared. Negative 3 times 4x is negative 12. And negative 3 times positive 4 is negative 12, right? Perfect. Now, coming back to my game. What is x squared plus 4x plus 4? X plus 2 squared. Awesome. And since we have an agreement, nobody will ask why there is a 4x in the middle, right? Right? Exactly, because of the 2 times the first times the second. That's how we save time. Signing an agreement on the first day of classes. Very good. So now the next set. So let's choose another one here.
But we can come after the class.
Say it again.
Can we come after the class?
Yes. You can come anytime. I have office hours. I'll be more than happy to help you. Yes. So please choose another from the next set. C. Very good. So we have 5mn plus m squared minus 150n squared. Again, back to my strategy. I have to present descending order. And you could say, wait a minute. I see m and n. Which one do I pick? Well, it's normally mn, unless I'm told such and such variable is more important than the other. But I'm not. So I'm going to rearrange it in terms of m. M squared plus 5mn minus 150n squared. I continue with my strategy. It says factor out the greatest common factor including the negative leading coefficient if the leading coefficient is negative. Good. Do these 3 terms have anything in common? No. Is there a negative leading coefficient that I could pull out? No. So, is this a special product? Yeah. I said this, but I didn't remind you that this has to be a perfect square and this has to be a perfect square. If these two are not perfect squares, I will never think of this. The same thing here. This is a perfect square. Yay! But this is not. So this does not work. This is useless here. Okay, so then there must be something else. And the reason why this is easier than the last one that we are going to look at is because the leading coefficient is 1. So right now we are looking for 2 numbers whose product is, and the same numbers whose sum is. The product is this, negative 150. And the sum is this, positive 5. Yes, 150 is kind of a large number. So I have the following options. I either start thinking, okay, how do I find 2 numbers whose product is a negative number, which means one is positive and one is negative, and whose product is negative 150 and whose sum is 5. If I can determine that pretty fast, then I will look at 150 and present it in prime numbers. So it's 15 times 10, and this is 3 and 5, and this is 2 and 5. So in prime numbers, 150 is 2 times 3 times 5 times 5. Now I'm going to start or try to find 2 numbers using all these factors. Find two numbers whose sum will be 5 if one is negative and one is positive. Can I find two numbers? Very good. Indeed, 15 and 10. 15 and 10. So 15 and 10, and one of them must be negative because the product is negative 150. But since the sum is positive 5, which one is negative? Very good. So now I have the factored form. This time is not a special product. It doesn't work. So what do I get? Yes, but it's m. It doesn't matter. You're right. X or yes, plus 15n. Yes. Very good. So this is when a special product does not work. Like in this case, it does not. So this is this type, when the leading coefficient is 1. And yes, there is one more type. And let's choose one. And this is the most difficult one. So let me show you what we covered here. We covered this type in which we use a special product that we have the agreement on. And we covered this type in which the leading coefficient is 1. So now we are down to the last possible way. If this doesn't work, we'll say the polynomial, the trinomial is not factorable using integers. Okay, so let's choose from here. B. You said, I'm sorry? D as in dog. Very good. So 5x squared minus 26x plus 5. I encourage you to work on all these problems. Whatever you write on the right-hand side, multiply and make sure it's the left-hand side. That's how you check, right? Good. This is different because the leading coefficient is not 1. So again, I go through my strategy. Number 1, descending order? Yes. Greatest common factor? No. Negative leading coefficient? No. Special product? No. This is not a perfect square. This is not a perfect square. This? No, because the leading coefficient is not 1. So that's my last chance. In this particular case, the sum of the numbers I have to find is the same as before. This is the sum. But the product is different. The product of the numbers I'm trying to find is, and now I have to incorporate the leading coefficient in the product. So it will be 25. When the leading coefficient is 1, this is the product and I'm done. But when the leading coefficient is not 1, I have to multiply it by the free term. So, again, I think, okay, I need to find two numbers now whose product is positive. If the product is positive, both have to have the same sign. Both positive or both negative. But their sum is negative. There's only one option then. One more time. When the product is positive, both have to have the same sign. But if I know that their sum is negative, what sign will I have to have? Very good. So let's find two numbers, two negative numbers, whose product is positive 25, but whose sum is negative 26.
25 times.
Say it again.
Is it 25 times 1?
Yes, negative 1 and negative 25. The product is 25, the sum is negative 26. Now here's what happens next. I will rearrange this whole thing using the numbers that you just gave me. How do I do that? I copy 5x squared, I can't do anything to that. But instead of this, I write this as minus x minus 25x plus 5. Did I change the problem? No, I just replaced negative 26 with negative 1 minus 25. I did not change the problem. Now, if you go back and combine like terms, you're not going to reach anything. You're not going to reach your target. What we have to do next is factoring by
Grouping.
yes. So I cover the last two, and I look at the first two. What do these two have in common?
X.
Let's pull out an x. What is left in parentheses? What should I have in parentheses? Coming from the other two. Without even looking, I have to write it. There is no other way. How do I know it's there? Because I found two numbers with product is this and with sum is this. This must be there. Now I uncover and I decide what to pull in front. I have to have a sign and I have to have a factor.
-5.
Do you all agree with negative 5? Negative 5 times 5x is negative 25x. Negative 5 times negative 1 is positive 5. Now I have two terms, and they have a common factor, and I need to pull that out. What factor is common that I need to pull out?
5x.
Good. And now in parentheses, it doesn't matter the method you used. If you use the method with the options and stuff, I'm fine with that. I need to present the factoring by grouping because that's for polynomials anyway. So that's why I don't mess around with the other method. So it takes me 30 seconds or less, 10 seconds I would say, to check. 5x times x, 5x squared, minus 25x minus x is negative 26. Negative 1 times 5, negative 5 is 5. Now, if your answer is x minus 5 times 5x minus 1, it's the same thing. If this is the factored form, nobody can find another factored form. It's a unique way of factoring. Good. So now we can go to some equations, quadratic equations by factoring. So, for example, let's look at C. So 4x squared minus 18x equals 70. What type of equation is this? Very good. So how do I solve it by factoring? What do I have to do first? Yes, I have to set it equal to 0. Awesome, thank you. So 4x squared minus 18x minus 70. When I move a term from one side to the other, all I do is subtract. Change the sign. Good. Now look at these three terms. What two keywords we said are so important? They're keywords in this class or any math class. Okay. Keywords. I'm going to ask you all the time. Factor, simplify. Two keywords. Factor, simplify. I have an equation. I'm looking at it. I'm asked to factor and solve. I will simplify it first. How? Divide both sides by. No cell phones in my class. Please put it away. Please, I see it. I see it. Please put it away. Please, please, please. Thank you. Yes, we divide both sides by 2. So please tell me what you get. There is nothing to think, right? It's 2x squared minus 9x minus 35 equals 0.
Why divide by 2?
To simplify the equation. So now, it's in descending order. Greatest common factor, none. Negative leading coefficient, none. It's a trinomial, so I'm looking at this. I try the special products first. Does the special product work here? No. Is 2x squared a perfect square? Is negative 35 a perfect square? No. Okay. Now, is the leading coefficient 1? I wish. So this is my last chance of factoring. Okay. How do I do it? Yes. So we need to find two numbers whose product is, and the same numbers whose sum is. Careful, the sign is crucial. Yes, and the sum is negative 9. Again, you can say 70. Oops, such a big number. Let's split it up.
35, not 7.
So this, good? So 70 is 7 times 10, and 2 and 5. So I'm looking at 2, 5, and 7. I need to come up with two numbers, both positive, both negative, one positive, one negative. Which one? Two positives, two negatives, one positive, and one negative. Which one? Right, because the product is negative. Awesome. So I have to come up with, using everything here, I need two numbers. So negative 14 and 5. Awesome. So now how will you change the equation? What would you write? You will write 2x squared. Very good, minus 14x plus 5x minus 35 equals. What method do I use next? Very good. From the first two. Awesome. In parentheses. In parentheses from the other ones. And don't forget this time to write equal symbol and 0. If you do not, you're not going to solve. So, what is in parentheses? I refuse to look. Because if I look, I could make the mistake and write x plus 7 and I mess up the whole thing. Who knows? What do I have to write before I look? X minus 7. Now I look. I need sign and factor. Plus 5. Without the sign, I mess it up. Okay, so what is common then? Awesome. And in parentheses, don't forget the equal symbol and 0. Good. Now we use the zero product principle. If a product of two factors is 0, what are the options? How can I get a product of two numbers to be 0? If the first or the second equals 0. So if the first factor is 0, I get x equals. I have to move negative 7 from one side to the other.
Oh.
Right? Because negative 7 minus 7 is not going to be 0. 7 minus 7 will be 0, correct? And the other one, 2x plus 5 equals 0. So x, I move 5 to the other side. It becomes negative and divide by 2. Negative 5 halves, correct. So this is how we solve by factoring a quadratic equation. That's our first method. Method number 2. And then I'll tell you which one, how, when to use. In method number 2 is taking square roots from both sides of an equation, of course. Let's say I have x squared equals 9. A quadratic equation has how many solutions? Absolutely. Degree 2, 2 solutions. Degree 3,
There's solutions.
degree 4, and so on and so forth. Perfect. Like here, we had an equation that was quadratic. We got 2 solutions. Okay, so assuming I want to factor, I have no problem. I will say x squared minus 9 equals 0. And I have my agreement. Number 3. How do I factor this? Very good. Then I get 2 solutions as 3 and negative 3 as we discussed with the zero product principle. No big deal, right? Let's say we are not going to factor. How do I get the same solutions? Here's another way, which is taking square roots. I see the cell phone under the table. So I take the square root from both sides. The left-hand side should be the absolute value of x. This is what it should be. I should write. The square root of 9 is 3. And from here, I will have 2 solutions. Let me cover this and ask you this. What should I have right here so that in absolute value, I get 3? Right. Right? The absolute value of 3 is? No. The absolute value of 3 is 3. And the absolute value of negative 3 is? Good. So then x equals 3 and x equals negative 3. However, knowing that, we omit this step. I always show it because when students write x equals 3, I have to say no. But what is the correct answer? Plus or minus. So when we take square roots from both sides, we expect 2 solutions. So we take the square root from both sides. Instead of writing this, which is the correct step, instead of writing this, we go directly to the solution and we put plus or minus in front of 3. Okay? So this is the principle of taking square roots. Now, why would I do this and not factor? I'll show you why. In this particular case, it doesn't really matter. If you give me this equation or this, if you give me this equation, I would probably take the square root, but if I factor, it's still in a blink. But let me show you one in which it's not a good idea to factor. It's a bad idea to factor. Here's an example. No, here I will not square, move 16 to the other side, set it equal to 0, and find solutions. No, I will not. Here, this is a particular example. It's specific, typical for taking square roots. Otherwise, it would be way too long to square this, subtract 16, combine like terms, and find blah, blah, blah. So the left-hand side is 2x plus 1. What about the right-hand side?
4.
No.
Plus
Yes. Good. So I will have to subtract 1. And divide by 2. I have to separate the 2 solutions. When the top is negative 1 plus 4, I get,
plus or minus 3.
no. When the top is negative 1 plus 4, the answer is 3. So x equals 3 halves. When the top is negative 1 minus 4, careful. Yes, negative 5 halves. This is a typical situation for taking square roots. You will not see me factoring this one. It's not even factorable. So that's the use of the second method, specifically in these situations, which are more difficult than just saying x squared equals 1. Yeah, okay, I know, I factor and I get plus or minus 1. Here's a third method. You're not going to like this one. I personally don't. but it's useful for something else, not for this. We study it here. It's called completing the square. It's not useful in this situation. We learn it now because it's useful for something else. But this method alone will not solve the equation. I repeat, will not. So once we complete the square, we have to come back to this method and take square roots. So this method alone is not correct to say that it solves quadratic equation. It's correct to say that after I complete the square, I will use taking square roots to solve the equation. That is correct. But this one alone will not. Okay. So let me choose a problem from your book this time. On page 167, I'm looking at problems 47 through 64. So the math department recommended 47 through 64, these 4 problems. As you see, they're not putting a lot of emphasis on this, but I have to show you the method. So let's look at what they said, which is 57. Okay. So let's look at 48. And that is x squared plus 6x equals negative 8. Okay, this is a quadratic equation. No, I will not factor. I'm told not to factor. This is a method that I will never use ever in solving quadratic equations unless you force me to. So if a problem on a test or a final exam, blah, 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 it's asking me to complete, I have no choice. But otherwise, if I'm not told or asked to complete the square, I'll never do it. Okay, so I cannot factor, even if it's factorable, and I'm told I can't take the square root. It's not ready for taking square roots anyway, so I'm asked to complete the square. What does that mean? It means this. To look at the first 2 terms, everything is descending order, correct? So I'm looking at the first 2 terms, at the term with x squared and the term with x, and I'm asking myself, what could be the 3rd term that I should have in here, plus what, so that this becomes a perfect square? And why 9? And how did we get 9? Awesome. How did we get 9? Right, so you identify that the other term has to be 3, correct. How do we do this? Okay, yes indeed, we're adding 9, and I have to add 9 to both sides of the equation. So I remember I have a balance. The equation is a balance. 1 pound, 1 pound. If I add 9 here, right, I have to add 9 here. I can just add to one side and say, hey, it's still an equation. No, it's not. It's still a balance. No, it's not. So let me explain the concept behind finding the 9, which is this, the first 2. That's the concept. That 2 in there is the key from the formula. So in completing the square, first step is identify the middle coefficient. Okay, so let's identify the middle coefficient. Awesome. In step number 2, divide it by 2. It's the 2 from the formula in the middle. So 6 divided by 2 is? Good. Step number 3, square that number from the previous step. Step number 3, square 3. What do I get? Step number 4, add 9 to both sides and complete the square. So our equation, initial equation was this. I am adding 9 to both sides. X squared plus 6x plus 9 equals negative 8 plus 9. One more time, notice it must be on both sides. Now you'll give me the left-hand side based on our agreement. How many times did I point to this in the last half an hour? See how important this is? So, please give me the left-hand side.
X plus 3.
Awesome, thank you very much. Please give me the right-hand side. 1. Now you see that I have not solved. I worked very hard. I complete the square. Now what?
No square root.
Exactly. So complete the square alone, not good enough. So, the left-hand side. The right-hand side. No. Always remember, the equation is quadratic. If you omit the plus or minus, you only get one solution instead of 2. I'm trying to be funny, of course. Sorry about that. So negative 3 plus or minus 1, I have to separate. So I'm moving 3 to the other side. If I make an ugly face, I'm hoping that that will stay in your memory and you'll say, oh, no, I can't, I have to put plus or minus. She's going to scream at me. Okay, so the negative 3 plus 1 is, the negative 3 minus 1 is, and this is the useless method of complete the square. It is very important method, but for something else. For circles, for hyperbolas, for other things, it's a very important method, super important method. I can't emphasize it enough, but not for this. Last method, I'm hoping that you're gonna practice this and we'll have more examples. Last method is quadratic formula. Okay, so here's the answer in case you ask me, okay, you gave me 4 methods. How do I know when, what do I do? So here's my answer. If you're given a quadratic equation and you're not told, so here's the quadratic equation, solve it, and you're not told specifically use this method or that method, here's what I would do. If it takes like this to factor, I'll factor. Otherwise, I'll not waste my time with big numbers and blah, 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 and changing it into a polynomial and factoring by grouping. Oh, no, no, no. If it takes like this, I'll factor. The other thing, if it's already arranged with something squared and just a number on the other side, which method will I use? Taking square roots and I'm done. When will I use to complete the square? Never. When will I use the quadratic formula? When I cannot factor. And the whole thing is not a perfect square with x in here and a number over there. Then I will use the quadratic formula. Okay? So quadratic formula is a lifesaver. Quadratic formula will always work. Completing the square will always work. Taking square roots will always work. The only one that may or may not is factoring. Not everything is factorable. Yes. So, but I will not go to the complete the square, right? So one more time. If it takes like this to factor, I'll factor. If it's already arranged for the square root, I'll take the square root. Complete the square? Never. Quadratic formula, when it's not arranged and I cannot factor, I will always go to the quadratic formula. So let's refresh our memory. Give me an equation. Give me a quadratic equation. It has to be already set equal to 0, otherwise the quadratic formula is not applicable. So make one up. X squared
Plus 23.
x
Plus
Let-
minus 7.
minus 7. Awesome. So this is the A, this is the B, and this is the C. And here's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. And this is something again for I sound like a in a Japanese environment. Okay, so x equals negative b, negative 23 plus or minus the square root of 23 squared minus 4 times 17 times negative 7 in parentheses, bless you. In parentheses, negative 7, you cannot have multiplication and negative 2 operation symbols without being separated, over 2 times 17, which is 34. I want to illustrate this with